everyone, welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're going to start with your CBNST class, and that has been the important one, which is being the computer based numerical and statistical technique. In that we have to start with your class that has been the 34th class, and where we had done 34 or third classes in the last session, where in that we had started with unit 1, which has been the computer arithmetic and rules of equation, which we had completed in the last classes. And today we're going to start with your unit 2, that has been the interpolations and computing, which we had even though started in the last classes. We had done many of the topics related to it. So today what we have to start discussing about, which is related to interpolating with cubic spline. Interpolating with cubic splines, and the same which we have to discuss here. But before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe to the channel, so that many and maximum people can get the information at once, and with you can also enjoy the video as well. In the interpolating with the cubic spline, where we have to discuss about the piecewise linear interpolation. In piecewise linear interpolation, we have to talk about it, where in this technique a single straight line is drawn between two data points. That shows the piecewise linear interpolation, that there is one straight line between x1 and y1 and x2 and y2, another straight line between x2 y2 and x3 y3, and so on. But the problem with the method is the interpolation is not smooth over the points as well. We'll talk about the cubic spline as well. In terms of cubic spline here, for the same, that is above problem that can be solved by drawing the quadratic through the x1 y1 and x1 xi plus 1 and xyi plus 1. Similarly, the other quadratic is drawn between your xi plus 1 yi plus 1 and xi plus 2 and yi plus 2, then so on. Those two quadratics join, that each of xi plus 1 and yi plus 1, at this point their slopes are made equal so that they are appear continuous. And we know that the smooth curve that can be drawn through a set of points with the help of a French curves, the segments drawn with the French curves appears to be the smooth, and curves, the segment drawn with French curves appears to be smooth and give better visual appearance at the point where they join each other. So they the type of the interpolation that can be obtained if the cubic curve is drawn through the type of interpolation that can be obtained if a cubic curve is drawn through the type of interpolation, and which is being xi yi and xi plus 1 and yi plus 1. Thus the approximation with a cubic curve is better than a quadratic curve. Those cubic curves are called cubic splines as well. So for the same, here we have to talk about it, that the interpolation using the cubic spline that you have to compare with, we observe the interpolation using the cubic spline is better than a piecewise linear interpolation as well. So for that, piecewise linear interpolations and cubic spline interpolations and the properties that we have to discuss here, so we go ahead for the same. This is on x-axis, this is of fx, this is at y1, x1, x2, x3, x4, x5 and x6. So it will be like it would be like this only. That has been the figure which we have, and that has been named as y1. This has been the y2, y3, y4 and y5, y6. So this has been the piecewise linear interpolation. Now we talk about for the cubic spline interpolation. On x-axis this has been x1, x2, x3, x4, x5 and x6, and this is for y1. This is of fx as well. So here it will be was like this. This is your f1x, this is your xy2, this is f2x, this is y3, this is a0, you can see this, and this is your f3x, this is y4, this is y5, f4x, and this is f5x, this is y6. So here what that we have, and this is the separation that we have. This has been the interval 1, and for the same it will be known as your cubic spline interpolation and properties that we talk about it. The another question is to discuss the cubic spline interpolation. Discuss cubic spline interpolations, that what we'll have to discuss here. Let's say that there is an n data points, and in those n data points there will be n-1 intervals, and we approximate one cubic spline for every interval, and therefore there will be an n-1 cubic spline. Thus in this that there are 5 cubic spline for 6 data points, and this has been illustrated. So here except the two extreme point, that has been the x1 and xn, and the other points are your coordinates. So thus x2, x3, x4 till xn-1, they are not here. So for their data points, if I'm going to draw, you can just go ahead. Drawing with a different pen so that you will get to know about it. Data point 1, data point 2, data point 3, data point n-1, and data point n. So for that, x1 comma y1, this is x2 comma y2, this is x3 comma y3, this is xn-1 comma yn-1, and this is xn comma yn. So this has been this is interval 1, this is interval 2, interval n. For the same it will be your cubic spline f1x, cubic spline f2x, cubic spline fn minus 1 x that we have. So this has been the illustration of data points and cubic spline between them. This has been illustration of data points and cubic splines between them. So the condition that to be satisfied for the cubic spline, that we'll discuss here one by one, so that it will be get to know about you. Condition that to be satisfied by cubic splines. So for that we'll have to talk about it, which is being here the cubic spline polynomial f1 fix is being chosen such that on each node, or that is your x2 x3 till xn minus 1, that following condition should be satisfied. So here for the same fi x plus ai plus 1 is your fi plus 1 and xi plus 1, where the condition lies that I is less than I is greater than equals to 1, and n is that is being less than equals that is being n minus 2 is greater and equals to I. So here fix is a cubic spline over xi and xi plus 1, and fia plus 1 x is a cubic spline, and xi plus 1 is a common point of joints of two cubic spline, with the same that the condition states that two neighboring splines should have same that value at the point of their joints, and with the same that the condition that states that the two neighboring splines f1x and fi plus 1x that should have same slope at the point of their joints as well. So for the same we go ahead here, and that's what we'll have to discuss as well. So on the same, we'll talk about the properties here. That properties of the cubic spline is that the cubic spline is defined to be as in the points, and which has been here that the ith data point that a cubic spline gives the values for y equals to yi and x equals to xi. The cubic spline, its derivatives is the second derivative, and all continuous over the all finite intervals that taken between x1 and xn. And every cubic spline fi1x is a polynomial of the degree 3. Equation of cubic spline, we'll talk about it, which is the cubic spline we have here. And for the same, when we are going to further solve it out, it will make that the types of spline is called that the natural spline, with the assumptions of n minus 2 and n minus 2 equation. Those of the equation that can be solved here. So we'll solve it out, and we'll solve it out by through a question here, so that it will be clear for you. The question is, the table of xi and fxi is given below. So the table will go ahead for the same. This is for x, fx, and it is 1, it is 30, 2, then it is your 15, it is 3, 32, 4, 18, 5, 25. So first we go ahead, find cubic spline for this table, and for the second one, find the value of fx at x equals to 3.5. So for that we'll have to solve it out one by one, and that to find it out for the same. And then after that we'll consider about the following concept that we'll have to talk about it here. But on the same phase, if I'm going ahead, yes, there are the two parts that what we'll have to solve it out one by one, and that is being the important one. So first we'll solve the part 1, which is being the cubic spline for this table here. So for the first one, it will be that the table of this numbers, that of the data points is I is equals to 1 and I is equals to 5. So for that, it will be made it like so for that it will be your xi, and this is yi equals to fxi. This is x1 equals to 1 and y1 equals to fx1, which is equals to 30. X2 equals to 2, x3 is equals to 3, x4 equals to 4, and x5 equals to 5. So here for the y2, which is equals to fx2 equals to 15, and y3, which is equals to fx3 equals to 32, y4 equals to fx4 equals to 18, and y5 is equals to fx5 equals to 25. So from the equation we get here, we will find it out. Xi plus 1 minus xi, f double dash x1 plus 2, xi plus 2 minus xi, f double dash xi plus 1 plus xi plus 2 minus xi plus 1, and f double dash xi plus 2, which is equals to 6 upon xi plus 2 minus xi plus 1, f xi plus 2 minus fxi plus 1 minus 6 upon xi plus 1 minus xi, which is being fxi plus 1 minus fxi that we have. Further we'll go ahead that we'll have to talk about it for the same, and that is the important one. So if the values of xi that are equally spaced in the above equation, that can be simplified here, and for the same it is xi plus 1 minus xi equals to xi plus 2 minus xi plus 1 equals to h, xi plus 2 minus xi equals to 2h, and similarly with the shorthand notations we talk about it. So it will be f double dash xi equals to y1 double dash yi, we can say that, and f double dash xi plus 1 equals to y double dash I plus 1. So for the same, f double dash xi plus 2 equals to y double dash I plus 1, and so on. Similarly we go ahead. So for the same it will be, when we go further, that putting the value shorthand notation in the equations, we'll get here that is being yi double dash plus 4 yi double dash plus 1 plus yi double dash plus 1 is equals to 6 upon h square yi plus 2 minus yi plus 1 plus yi. So for that, if the condition will be your from 1 is less than equals to I less than equals to n minus 2. This has been the simplified equation for the equally spaced data point, and for this example I equals to 1 to I equals to n minus 2, which has been 5 minus 2, and that has been equals to 3. So we obtain the following equation where I equals to 1 here, and for the same we'll get the value as well, and finding it out each and on solving the simultaneous linear equation, and y2 will get you we will be getting as an answer. So that y1 is equals to f double dash x1, and on the same case y5 double dash is your ffxy, and that is being equals to 0 as well. So we'll putting the value, so we'll get y2 double dash is equals to 67, and y3 double dash is equals to minus 7 59, and y4 double dash is equals to 50.5. And let us recall the cubic spline equation that we have your formula, and we'll put the value for the same, and that what will further finding it out, and what will get it is your fi x equals to 1 upon 6h yi a double dash plus 1 x minus xi cube minus yy double dash x minus xi plus 1 ka cube plus yi plus 1 upon h minus hyi double dash plus 1 upon 6 x minus xi plus hyi double dash upon 6 minus yi upon h x minus xi minus plus 1 here, so that we can have a condition as well on the same phase, and with the same references we talk about it. So here for the same, and that is fx1, and then we'll find it out for f1x equals to 1 upon 6, sorry, that is 1 f of 1x is your 11.167 x minus 1 cube plus 3.83 x minus 1 minus 30 x minus 2 that we get here, and that what we'll have to discuss as well. So for the same, when we'll talk about f2x, that will get your f2x equals to minus 1265 x minus 2 ka cube minus 11.167 x minus 3 ka cube plus 44.65 x minus 2 and minus 3.83, which is x minus 3 here. So that has been the f2x. We have your value here. For f3x equals to 8.42 x minus 3 cube plus 12.65 x minus 4 cube plus 9.58 x minus 3 minus 44.65 x minus 4. Now for the same, when finally I equals to 4, we'll get the value here, and that is the value will be f4x is equals to minus 841 x minus 5 ka cube plus 25 x minus 4 minus 9.58 x minus 5. This has been the x4 value we have. Thus, we obtain the 4 cubic spline to the interpolations to the given 5 data splines, and f1x is a cubic spline in interval 1 comma 2, and f2 we get here, that has been the cubic spline for the interval 2 comma 3. That has been f3x is a cubic spline in the interval of 3 comma 4, and f4x is being the cubic spline in the interval of 4 comma 5. So to the value we have here the second point for the same, that is to find the values of fx at x is equals to 3.5. So we know that x lies in the interval of 3 comma 4, and which has been in the interval of fx, which is f3x, and that fx equals to 3.5 and f3 equals to 3.5. We'll substitute x is equals to 3.5 in the equation of 3x here. So we go ahead for the same. fx equals to 3.5 equals to f3 3.5 equals to 8.42. f3 देखिए ये है, so इसमें हम रखेंगे वैल्यू 8.3, that has been 8.42, and 35 minus 3 का cube plus 1265 3.5 minus 4 का that is cube plus 9.58 3.5 minus 3 minus 44.65 is 3.5 minus 4. that we have here on the same phases, that is being equals to your 26.58625, and thus the interpretation y equals to fx at x equals to 3 is giving a spline interpolation will be 26.58625. For important point that the cubic spline information formula of the equation 3 that and equation 4 are applicable only if the values are x is equally spaced, and the cubic spline formula of the equation or that 5 and the 6 that we turn for the general formula for the application of any type of a data as well. So for the same we go ahead and that what we'll discuss about it. So here we're gonna end up with, and before ending it up, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel so that many and maximum people can get the information at once, and you can also enjoy the video as well. Other than CBNST, yes, we had done which is the sociology and software engineering. We had done reasoning, wherein that we had to complete a verbal reasoning. In that we had done general mental ability in the logic reasoning. In non-verbal reasoning we had done series in the logic classification, analytical reasoning, mirror image, water image, embedded figure, completions of incomplete part and figure matrix, paper coding, paper cutting, rule detection, grouping of identical figures, cubes and dice, dot situation, construction of squares and triangles, figure formation analysis, practice question set as well. In terms of it, we had done ER diagrams, we are dealing with English vocabulary, we are dealing with quantitative aptitude. In quantitative aptitude, we had started with arithmetical ability. In that, we had done operations on numbers, SCF and LCF of numbers, decimal fractions, simplification, square roots and cube roots, problems on numbers, problems on ages, stars and indices, percentage, profit and loss and averages. We are talking about 11 topic that we are dealing here. Other than computer-based numerical and statistical technique, we are in the unit 1, which is in the computer arithmetic errors. We have completed your floating point arithmetic, machine abscond, downs of error, chopping error, truncation error, associative error, distributive and the law of the floating point arithmetic, inherent error, error propagation, numerical instability, rules of equation, second order, second method, and Newton-Raphson method, fixed point iteration method, convergence of modified Newton-Raphson method, and to the multiple roots Birch-White method for the polynomial, Weierstrass method for the quadratic factor, and computer algorithm of these methods as well. In unit 2, we had started with interpolations and curve fitting, where we had done your algorithm and the error analysis of Lagrangian, the Newton's divided differences, interpolation, relationship in the various differences operator, piecewise linear interpolation, cubic spline interpolation, natural spline, Chebyshev's polynomial approximation, Langkos economization, and the power series. In curve fitting, we have to run with linear and nonlinear least square approximation. Third, conditioning in the least square method, Gram-Schmidt's process of orthogonalization, computer algorithm at least square curve fitting. In terms of unit 3, we have to cover up the differentiation and integration, where we have to cover up the method based on interpolations and finite differences, Richardson extrapolation and integration. We have to cover up the analysis of trapezoidal and Simpson method, Newton's curve integration method, Gaussian integration method, Gauss-Legrand method, Lobato integration method, Rodin integration method, and Johnson pertaining the integration method. In unit 4, we have to cover up the solution simultaneous linear algebraic equation. We have to cover up the Gauss elimination method, third, and conditioning system, condition numbers, excessive and relaxative method, rate of conversion, solution of ordinary differential equation. We have to cover up the single step method, Runge-Kutta second, third, and fourth order method, multiple step method, predicator and connective method as well. In statistical technique, we have to cover up the statistical hypothesis, test of hypothesis, type 1 and type 2, errors, level of significance, test involving the normal distribution. So here we're gonna end up with, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel so that many maximum people can get the information at once, and you can also enjoy the video as well. So thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Thank you.